etc., etc. So those data are extracted from the machine, and those data are feed to the virtual client, that is digital twin. So as I told, the digital twin is digital copy of original machine. Okay, and how we are going to make the digital twin means, the digital copy means we need to extract the data from the physical machine. Okay, it is a so we can assume that it is a 3D uh, animated file of original physical machine. And after extracting the data from the physical machine, and we are going to process those data, and we take decision by using some AI models in digital twin, and those data can be displayed on the user interface devices. It may be a mobile phone or some other dashboard. Digital twins key characteristics, and we'll see some of the main characteristics of digital twin. The first one is real-time data synchronization. So the digital twin always stays updated every second with the latest data, okay, from the real machine. So, for example, if we want to find the temperature or monitor the temperature of the machine, okay, and the temperature has to be updated at each and every second, and then only we can have a proper prediction of our system functionality. So the real-time synchronization is very much essential in digital twin technology. And the next one is predictive modeling using AML. So the data can be extracted from the system to the digital copy or digital twin by using sensors. And after we get the sensor from the physical machine, we need to process the data. Okay, and we need to process the data, and the system, the AML model is going to take some decisions. For example, if you want to uh, monitor or track the functionality of the motor, okay, and the functionality motor, you can predict the functionality of the motor by using the vibration level of the motor. Okay, and if we take vibrations of motor by using vibration sensor, and by analyzing those vibration threshold level, and you can predict the functionality of the motor and failure uh, time of the particular motor. Third one is bidirectional control. So as I told, it is a digital twin is a simulation, digital copy, or we can call it as simulation. Okay, we can call it as simulation, exact or exact simulation of original machine. Okay, here the data is bidirectional. Okay, we send the data, that we flow the data in both ways. Okay, so from real machine to twin. Okay, so we need to extract the data through the sensor uh, from machine to twin, and that is for monitoring purpose. So after monitoring, the twin is already I told you that, the twin is having a semi AI model. That AI model get the data from the real machine, and it processes the data, and it takes some decision based on our user application, and the based on the decision, again it will flow the data to the real machine. Okay, and that is for control purpose. Okay, so once you pick the our expectation, the digital twins take the decision, and from the digital twin we'll give the control signal to the real machine and to make the adjustment to meet out our expectation. For example, if the digital twin detect overheating, suppose the machine, we need to keep some proper temperature for the particular machine. If the machine get overheated for wrong time learning due to wrong time turning, and the twin take the decision, if the twin meet the particular temperature, and twin is able to control or reduce the speed of the machine to reduce the to balance the temperature of the machine. And next one is scalable for system, factories, and network. Okay, and the digital twin is scalable. Scalable in the sense you can make a copy of small object to large complex system. For example, you can make a digital copy of a simple machine, or you can make a digital copy of entire factory, or you can make a digital copy of whole city traffic, or you can make a digital copy of 5G or 6G wireless network, the complete wireless network. And even though if you are making digital copy of small system to complex system, it works effectively. Okay, the system may be a small or big, that doesn't matter. The digital twin works effectively. So that is a main advantages of digital twin system. The next one is components of digital twins. What are the components of digital twin? As I mentioned, the digital twin is a simulated or 3D animated copy of original machine or original system. Okay, and that digital copy will replicate your original system. Okay, how the system works exactly, that same functionality in the same manner the digital copy is works. Okay, so this is how we make a copy of original machine. Okay, so as I told, digital twin is a extended version of IoT technology. Okay, and now we can see the components of digital twins. Okay, as I told, the first one is a physical entity. The physical entity or machine. As I told, the machine may be a simple machine or a complex machine. It may be a device, or it may be a building, or it may be a city, or it may be a network, or it may be a kind of human body. Okay, the physical entity is the first component of the digital twin. Okay, what machine we are going to extract the data, what uh, uh, from what we are making copy. So that is called physical entity. Next one is sensors. So if the digital copy, if you want to proper functional, you need to have exact data. Okay, so the data can be taken by using sensors. So we know what is sensor. So sensor is a device which sense and convert a physical quantity into electrical quantity. Okay. So we need to have proper data of original machine. For example, if you want to extract the machine temperature or vibration or pressure, speed, motion, location, etc., etc., all can be taken by using sensor. So sensor is a very important component of the digital twin. Okay. And the next one is connectivity layer. So once the first one is physical entity, that is your real machine that we want to make a copy, and the next one is sensors. So sensor, we get the data by using sensors from the machine, and the third one is connectivity layer. Okay, after extracting the data by using sensor from the machine, we need to send a data. We need to communicate those data to somewhere. It may be some other machine, or it may be a cloud, or it may be a server, etc., etc. You need to send or communicate those data, those sensor data, to the some other location, or it may be a cloud, or it may be some other machine, or it may be a digital twin, that is your digital copy. Okay, so for that we need to have connectivity protocol like Wi-Fi. So we know that these are the connectivity protocol, that is Wi-Fi, Bluetooth, and LoRaWAN, Zigbee, 5G, 6G. We have some other protocols also like NB-IoT, NFC, etc., etc. And we should have some connectivity methodologies. Then only you can share a data, send a data from machine to the digital twin. Next one is data processing or edge layer. Okay. So as I told, you need to send this machine data by that is extracted using sensor through this connective methodology like Wi-Fi, Bluetooth to some digital twin. Okay. So before we reach a data, we send a data to digital twin. We have some kind of layer called edge layer. Okay. So after uh, collecting the data from the sensor, uh, before we are going to feed a data to the cloud or digital twin, we need to process the data, pre-processing, filtration, and for a low latency decision making. Latency in the sense delay, okay, at the edge, okay, and those kind of processing. Okay, you need to reduce the delay of the data, and you need to reduce the noise, and you need to do some pre-processing. So that can be done in edge layer. So the edge layer is located after the connectivity layer and before the digital twin. Okay, so by using these processing, then we send a data to the digital twin. Next, the cloud or the platform layer. Okay, the cloud, we know that the cloud is a storage. Okay, it is a memory. It is a large memory. Okay, so after extracting the data from the machine, and the cloud, this memory is getting the data from the uh, machine through some kind of connectivity methodology after pre-processing by using edge layer, and we can have a data in the cloud. Okay, and the cloud is we can use the cloud as a simple storage device, or many kind of cloud service provider is having some kind of AML model. Okay, the cloud itself, we can have a customized AI and ML model. So we can have a data in cloud, and after getting data in the cloud, and the AI/ML model will process a data based on the user expectation. Okay, based on our algorithm. Okay, and that will fulfill our expectation, that user expectation. Okay, and after processing based on our AI and ML model in the cloud, and it takes some decision. Okay, and that decision will lead to our user expectation. The next one is simulation or virtual model. Okay. So after taking decision and all, you need to simulate. You need to create some virtual model, okay, or the mathematical model. It may be a 3D model or a mathematical model of the physical entity. Okay, physical entity means the system, the original machine. Okay, we get the data from the physical entity, that machine, by using sensor, and we transmit the data by using connectivity methodology. And after before we feed the data to the cloud, we do some pre-processing in edge layer, and after we receive a data in a cloud, in cloud itself, we are having A and ML model, and the A and ML model works to process the data, that sensor data, and it takes some decision. Okay, and that decision will control the simulation engine. Okay, and after the simulation is kind of 3D model or a mathematical model of the physical entity. Okay, so after doing this simulation, which means that that digital twin is updating the machine data. Okay, the sixth point is, so here we are telling that the 3D model or mathematical of the physical entity, and here the digital twin is updating is system functionality or behavior based on the sensor data. Okay, and finally we should have some visualization uh, system. It may be a dashboard, or it may be a 3D display, or it may be some kind of AR VR interface for monitoring the functionality of the system, or it may be by using virtualization, you can control the machine also. If you have a feedback mechanism from the final model, that is visualization, to the machine, and we can able to control the system also. And why do we need a digital twin? So mainly the digital twins used to predict the failure in an industry. So that is the main purpose of using digital twin. Before we are going to do exact operation, uh, you can predict the failure. So that is a main uh, advantage of digital twin. Okay. So here we are having some of the subtopics. That is first one is predictive maintenance. So as I told, detect problem before they occur. For example, if you have a machine, a big machine like motor, a turbine, a big vehicle, we do not know when the failure will occur in the particular machine. Okay, by using this digital twin technology, so we can predict the problem by using a various kind of data. Okay, so as we know, the digital twin is a digital copy, and this digital copy is continuously getting the data of the machine by using sensors. Okay, by using those data, we can predict the failure before physically it is happening. Okay, and the next one is reduce operational cost. Okay, so if you are able to detect the problem before it occurs, then you can have a service. You can have a service, or you can minimize the operational cost. Okay, and that will minimize the downtime and improve the resource efficiency. And the third one is real-time monitoring. You can have a continuous monitoring over your system. Suppose if you are raising some kind of sensitive machine, you need to, for example, aircraft. Suppose the system which is using nuclear power plant, you need to. Those systems are a sensitive system. Okay, you need to continuously monitor, or you need to continuously tracking the performance of the system. Okay, so with the use of digital twin, you can able to do that. And the next one is improved design and prototyping. Improved design and prototyping means since you can simulate the behavior without manufacturing a physical prototype. Okay, suppose if you want to design, if you want to change some of the, if you want to add some of the component in your physical system, if you want to improve the physical system functionality, you don't want to add a physical component in your physical machine. So already you have a digital copy of your original machine. Virtually, you can add some the particular extra component to improve the functionality without spending much time and then cost. Okay, and by using this, you can improve the functionality of the prototyping. Okay, as well as your design. The next one is optimization of operations. So, and this digital technology is you can, by using this DT, you can increase the productivity. You can improve the productivity, as well as you can ensure the safety of the system. And another important thing is you can use the energy efficiently. And the last one is data-driven decision making. The digital copy or digital twin of your original image is continuously getting the original data through the sensor. Okay, so you can have a actual system functionality in your digital twin. So you can have exact decision on your design. You can have accurate decision on your design, or you can have a real measurement of your original system functionality for simulation. And Next one is the area where we can employ digital twins. The first one is manufacturing, that is Industry 4.0 field. This digital twin is mainly used in manufacturing sectors like CNC machine, robotic industries, production line, assembly line, quality control, etc., etc. So these process are repeated one. So CNC machine operation, robotic, assembly line, production line, QC control. So these processes are repetitive one. This digital twin is mainly used in this kind of manufacturing sectors like Industry 4.0 setup. The next one is smart cities. So as I told, so digital, we can have a digital copy of simple system or medium system or a factory or city or entire network. Okay, and the digital twin is works effectively from simple system to network, complex network, and you can have a digital twin of an entire city. So if you are having a digital twin of an entire city, you can easily manage the traffic and you can easily effectively distribute water and you can easily effectively manage the energy consumption of the city. So Singapore is implementing this digital twin, digital copy of that cities to develop into smart cities. Next one is healthcare. We can have a digital copy of human also. If we are having a digital twin of patient or medical device monitoring, the medical system, and we can have some personalized treatment that will give the big impact in medical field. And next one is a smart building. And this you can have a complete digital twin of the entire building. So after having a digital copy of entire building, you can optimize that high voltage AC appliances, and you can have a better energy management. You can do better energy management, or you can have a good safety of your entire building. And this is the one of the another major area that we can employ in digital technology, digital twin technologies. That is one is aerospace and automotive. So we know that aircraft is a very costly manufacturing sector. Suppose if you want to do any modification in the aircraft engine, you cannot have a prototype or you cannot have a product design uh, regularly. Okay, so if you want to improve the functionality or if you want to do some modification in your design, you cannot have easily. Okay, because it takes much time and as well as cost. So those kind of machines or engine, if you are having digital copy or digital twin, okay, and that will be very easy to improve the functionality or improve the productivity as well as uh, it will reduce the cost. Okay, and another important thing is the EV sectors. That is, you can have a digital twin of EV battery, and you can have a good battery management technique by using digital twins. And another important thing is autonomous vehicle. So the Tesla car is digital twin of their Tesla is having a digital twin of their car, and the digital twin is able to monitor the motor functionality as well as battery functionality. Next one is power and renewable energy. So, as I told, it's if you want to do any modification, if you want to track the monitor the complex system like a wind turbine, big solar panel, and the entire city power grid balancing. Okay, you cannot change the system regularly. You cannot have a continuous tracking regularly. Okay, and if you have a digital twin of wind turbine, solar asset, and power grid balancing of entire city, and you can easily monitor and you can easily track the functionality of the system. Okay, so this is another big area that we can employ digital twin. And then the next one is the logistic and supply chain. This is a very critical thing in manufacturing sector. This is a very important thing in supply chain and the logistic also. Okay, the warehouse management. If you have a digital twin of your warehouse management or fleet operation, and that will reduce the operation cost of your industries and factories. And so in the earlier slide, I told that you can have a digital twin of simple system to a big wireless communication system. Okay. And you can have a digital twin of entire 5G or 6G network from wireless sensor nodes to a satellite. You can have an entire digital twin, digital copy of your communication system. Okay. And that will make effective communication in your 6G, 5G or 6G network, and you can easily avoid the noise and you can easily predict the interference and you can have a maximum coverage in your entire communication system. Okay, is digital twin used anywhere in the world? Is it virtual or it is an idea or we are using anywhere in the digital one? The answer is yes. We are using digital twin in many of the top industries. For example, Siemens. So as you see, the real machine. Okay, they are making digital twin of the entire machine. Okay, by using this digital copy, they can easily monitor or track the machine functionality. So already they implanted some many sensor within the physical machine. By using those sensor, um, that digital twin is updating the real machine functionality. Okay, you can have a continuous monitoring and you can have a control over the real machine. Okay, so Siemens is producing digital twin of the simples and as well as complex machines. And GE Aviation, so is a well-known aircraft jet engine manufacturing industry. So they are also having the digital twin of their engine functionality. So we know well-known company Tesla, as I told, they are implanting the digital twin in their Tesla car to monitor battery and motor health. So they are they're using a lot of sensors. They're using a lot of sensor and communication methodologies. And so already they have a digital twin of their Tesla car. So all the functionality, the motor speed, the battery health, and motion control, and the object detection, everything is updated in the digital twin. Okay, and that is very useful to find the failure rate in future, and that will improve the safety of the Tesla car. And they are keep on updating their uh, vehicle performance by using this digital twin data. So as I told, the Singapore smart nation that they are implanting, they're they're having complete digital twin of their entire city. for their urban planning. Okay. By using this digital twin, they can do anything. Okay, they can distribute the water effectively. They can have a good energy management. They can have a good infrastructure. Okay, and they're having lot. They're using a lot of sensors and communication protocol to have a real-time updation from the entire city. Okay, so Amazon, Microsoft is one of is are the famous cloud service provider. So they are also using giving digital twin services for IoT and cloud system. For example, if you want to build a CCTV dashboard with the AWS IoT Twin Maker, the AWS IoT, the AWS giving provision called IoT Twin Maker. So by using this AWS IoT Twin Maker, we can easily create a dashboard for having a video feed, and we can have a sensor also, a sensor data also. So this twin board is allows to integrate camera video feed as well as sensor data. And economic impact of digital twin. So global digital twin market size, and in 2023, the due to the digital twin implementation, so the global market size has increased to 13.3 billion, and we are expecting to reach 110 to 130 billion by 2030. Next one is economic benefit for industries. So in manufacturing industries, the machine cost reduces up to 30 to 50 percentage, and improve the productivity by 10 to 20 percentage. Okay, and we also cut the maintenance cost by 25 to 35 percent in manufacturing industry. These are the main thing. Uh, uh, you can reduce the machine runtime, and you can improve the productivity, and you can reduce the maintenance cost. So this data is taken from the Siemens McKinsey Industry 4.0 report. So by using this digital twin, this industry has achieved the above parameters. And energy sectors, the GE renewable energy is one of the well-known uh, energy sector. And by using this digital twin technologies, their energy output increase up to 20%. And the maintenance is one of the biggest issue in energy sector. So by using this digital twin technology, they reduce the inspection costs up to 35%. And the next one is the automotive. So automotive industry is one of the main industry that we can employ, we can effectively utilize digital twin technologies. And predictive maintenance in automobile industry, by using the digital technology, the predictive maintenance reduces service cost by 15 to 20 percentage. Okay. And you can have a faster R&D. You can do R&D very fast manner. And because if you want to do any modification in your automobile industry, you can You don't want to make entire product physically. You can have a digital copy. In that you can add a component digitally, and you can have a simulation, and you can get the output as the original machine gets. Okay, because your digital twin is the exact version of your original system. Okay, and the digital twin behave exactly as your original machine function, and we are getting a continuous data and exact data of your original machine through lot of sensors. Okay, so you can have an exact functionality of our original machine, and if you want to modify your original machine, you don't want to modify the exact physical machine. You can just modify the digital twin by adding some extra feature digitally, and you can have a simulation, and you can get the output, and the output will be same as your original machine. Okay, so that advantage will lead us to have a good R&D uh, process. Okay, and that will uh, reduces the cost up to 30%. And another important industry in is aerospace. So aircraft engine digital twin saves up to $2 lakhs per year. Okay. So this report has taken from the GV Aviation. Okay. So per year they are saving $2 lakhs in engine design, aircraft engine design area. And smart building. So as I told, we can have a good plan in energy management. It may be a building, or it may be a city, or it may be a network. Okay. So in smart building, the high voltage AC optimization reduce energy consumption up to 30%. Okay. And we can have a good space utilization methodologies with the use of digital twin. Okay, that can be up to 15 to 20%. So as I told, you can have a digital twin of your patient also. Okay, and that personalized treatment by using digital twin of patient reduces treatment cost by 8 to 12%. And the 20 to 25% of the equipment downtime cost is also reduced with the use of digital twin technologies. The future scope of the digital twin. And now we are using 5G, and the speed of the 5G is almost 1 terabits per second. And if we are moving towards 6G, and we are almost expecting 6G in 2030, okay, and we can have a data speed up to 10 gigabits per second. Okay, and if we are using digital twin with that much network speed, okay, and we have a good latency, a low latency in 6G. Okay, and that will lead us to have some kind of holographic twins. Okay. So that field is one of the emerging field in the 6G network area. So if we are integrating 6G network with the digital twin, we can have low latency holographic twins, okay, for real-time monitoring. Next one is AI-driven autonomous twins. So twins making independent decisions. Okay, twins making independent decisions and optimizing system automatically. Okay, nowadays the system in digital twin, that AI model, they get the data from the machine through the sensors. Okay, and based on the data, previous data and the present data. It takes some decision based on the AI model that we are designing. Okay. In future, autonomously the AI model take decision based on the data. Okay, and that will improve the functionality, and that we can have better accuracy, or that we can have a good prediction as compared to present digital technologies. And metaverse AR and VR integration, and you can integrate that AR VR with the digital twin, and you can have a uh, immersive environmental training, and you can have a good visualization, and you can have a good simulation in future. The next one is a human digital twin, and in future, by using this digital twin, we can have a personalized treatment, and it is possible to have virtual surgery, and it is also possible to have a lifestyle of each and every human. You can also able to predict the lifetime of the human also. Okay, and if we have a uh, digital twin of the human, and the drawback. So far we have seen many advantages of digital twin. So we have some limitations too. The first drawback is high initial cost, because as I mentioned, we are getting the data of the machine with the use of sensor, and that data will feed to the cloud service, and we need to have some kind of simulation software in cloud. We are using some AI model in cloud, and all these services or components and services are expensive. Okay, it's highly expensive. You need to spend a lot of money for that a digital twin technique. And the next one is a complex implementation. Okay. And you need to have IoT devices, AI model, and strong domain expertise. Otherwise, you cannot have exact digital twin of your original machine. Okay. You need to be expert in IoT as well as AI as well as domain. Okay, then only you can have a duplicate copy of your original machine digitally. The next one is data securities and privacy risk. This is another main challenges in digital thing, because we continuously taking a data from the machine. Okay, someone can able to hack the data, and that will lead us to have a wrong decision on your digital twin. So that is the biggest challenge in digital twin. Next one is scalability issues. So as I mentioned, you can have a digital twin from simple system to complex system. And if you are having digital twin of larger system like city or factory, we need to have massive resources. We need to have massive computing resources. Okay, you further you need to have a lot of infrastructure. Then only you can have a digital copy of a large system like factory and cities. So this is one-time investment. Once you have those kind of system, you can have a better performance as compared to previous one. This is one of the main drawback. Okay, and the fifth one is accuracy depends on data quality in the data. So we sensor, we take a data uh, of a machine with the use of sensor. If the sensor is not able to get exact data, if the sensor is get poor data, or if the data is not accurate, okay, that will lead to incorrect simulation, and that will lead to wrong prediction in the AI model. Okay. Sorry. And the sixth one is integration challenges. So already we have some kind of system in physically. It may be a it may be a simple system or a city or a network or factories, and it is very difficult to cope up with the old system to digital twin system. That's the another biggest challenge in digital twin technologies. And that's all about my solution. Any queries?
Participants, any queries?
Sir, good evening, sir.
Yes, sir.
Sir, I'm getting the information through ChatGPT or some other platform, sir. But
Yes,
I
sir.
don't know how can I evaluate for the exact meaningful sentence, sir. Now you say like that. Now we are using the 5G. Upcoming we are move on for testing on the 6G itself. So we can getting the data within a second. So what are the things which should be shared with us?
Sir, your
But
voice is breaking.
who will, so now I am audible.
Oh, yes, sir. Yes, sir.
So whatever the data we are getting from the source of like ChatGPT or Gen AI like that, uh, I have a
Okay.
doubt. Who will be about the content, sir? Whether we are getting the data is exactly right, or we want to in depth to we want to analyze it, sir.
Sir, sir, we are actually the data is not taken from the source like ChatGPT. So we have to take the data from the machine. Actually, we want to duplicate the machine. For example, if you have a car, you are making a digital copy of your car, simulation version of your car. Okay, suppose original simulation version of your car. Okay, and that simulation version is called digital twin. Okay, and that digital twin we have to design, or we have to make a copy of your car as your original car function. For example, if you give an accelerator to your car, if the car is reaches uh, a 70 to 80 kilometer within 3 to 4 seconds, the digital copy, if you are giving accelerator in digitally in your digital twin, it has to reach the same speed within 3 to 4 seconds. So like that, we have to make a copy of your original car. Okay, and in your car, you have to fix many kind of sensor to monitor your car functionality. For example, speed. You want to monitor the speed. You want to monitor the battery performance. You want to monitor the temperature of the engine. You want to monitor the vibration of the engine. Further, you have to implant many sensor in your car, and that sensor sends the real data, and that data has to be updated on your digital copy. Okay, so for that you need to have some connectivity methodology. So as I mentioned, and in your car you need to have sensor. That sensor, along with sensor, you need to have some kind of communication methodologies, like it may be Bluetooth, or it may be a internet, or it may be a Wi-Fi, or it may be some other communication protocol. So from the physical car, we are taking a data with the use of sensor. Okay, and that sensor meanwhile transferring the data to your digital copy. Okay, so the digital copy, the digital copy means digital twin. The digital twin is getting a real-time data from your original car. Okay, and it updates. Okay, and it update its functionality. Okay, so then if you want to do any modification, or if you want to do any simulation, you don't want to depend on your original physical car. You just uh, simulate with your digital copy. You can predict the failure, or you can have you can improve the design. So that is what we are doing in digital twin. It is car. Car may be a machine like CNC machine, or it may be a simple system, or it may be a building, or it may be a entire city. Okay. So the main thing, we need to make exact copy of original system. Okay, original system digitally, and that original system information has to be updated on your digital copy, and uh, possible with only using IoT sensors.
Okay, sir. Thank you, sir.
We are not we are not taking data from the source like ChatGPT, sir.
Yes, sir.
And
Participants, any other questions? Participants, any other questions?
That's it, ma'am.
Okay, sir. So, shall we wind the session, sir?
yes, no, if no questions are there, then we can wind up the session.
Okay, sir. Thank you. Thank you, sir, for your wonderful presentation. On behalf of our Karpagam Academy of Higher Education and the organizing team, we extend our heartfelt thanks for delivering such a insightful and engaging session on digital twin in IoT and wireless systems. Your expertise in bridging the concepts of digital twin technology with IoT and wireless communication provide immense clarity and inspiration. The way you highlighted practical applications, challenges, and future opportunities gave participants a deeper understanding of how these technologies can transform industry and research. We truly appreciate the time, effort, and dedication you invested in preparing and presenting this topic. Your contribution has enriched our knowledge and sparked meaningful discussions that will surely guide future exploration in this domain, sir. Thank you once again for sharing your valuable insights and for being a part of this learning journey, sir. Thank you, sir, for
Thank,
accepting the invitation
thank,
once again.
thank you.
Thank you, sir.
Thank you, sir.
Dear participants, I kindly request everyone to post the feedback form for this link, and it has been posted in the chat box. I will be posting now. Dear participants, kindly post the feedback form for this session, and we can meet tomorrow by 6 p.m. for the next session. Thank you for your patient listening, and thank you all. Once if you have posted the attendance means, kindly leave the link. Thank you.
Mhm.
Dear participants, once if you have posted the feedback comments, kindly leave the meet. Thank you.